Good morning. Right, I rolled out of bed, and here we are again, once more into the reach. What they say. Let's see. Right. So what are we doing? We're trying to make pick and place procedure software, but part of this is the workflow side of things. And in order to get a decent workflow, you need to be able to go from like a design file, and then have a list of parts, and then maybe that one of the parts in your EDA tool will match one of the actual parts that you can buy from a supplier. And we need some way of choosing one of the potential ones that you might already have. And we also need to define this, all the mappings and all the parts and all this kind of stuff. And we made good progress doing that so far. That's what we're sort of trying to do. All right, so let's have a quick look at some code. Here we go. Right, some code. So yesterday, things looked like sort of more or less like this, where for a given part, you could have, for a given placement, you could get a particular part. And this is all well and good. But if you've got the situation where your EDA tool says, I've got this kind of resistor, but it might be that, you've got this kind of resistor and you've got the part that works for it. But it might be that you are buying some new stock or whatever because you can't get the old part anymore and you've got to use a new part. So there can be a situation where at any given time, you've got more than one part that you could put on a PCB. That's what we're going to try and deal with today. So if I undo my deletion, we have this. So yesterday I made this work. What this says to the user running this tool is that we're going to use this part, but we also found this part and we're not using it. And we're using sort of these brackets around it to say that it could be used, but we're not using it. And the current process is that it basically picks the first mapping, or uses the first mapping that it finds in the list of mappings. But that isn't necessarily what you want. So what we need is some way of asking the user which one they want to actually use. Morning, Darkman. So we need some way of asking the user which one they want to use. So that's what we're going to try and do today. I don't really know how we're going to do it yet, but we're going to find out. So yeah. So there's a few different ways of doing this, and remember that we're trying to build a system that we can eventually write a GUI for. But the whole process of like mapping parts and defining parts and all this kind of stuff is the same regardless of whether you've got a graphical user interface or a command line interface. And the logic needs to be the same to determine, how everything matches up. That's all going to be the same. How the questions are presented to the user, however, and how the results are presented to the user is completely different. But the underlying process and workflow for both needs to be the same. So one of the things we can do is, let me see if I can find this. Here we are. Right. So one of the things we can do is potentially use crates like this. Rust, crate, what's it called? It's called Inquire. Yeah. Right. So Inquire, I've not used this before. So we might see. So here's a little demo. Let me see if I can zoom in this. There's a little demo video here. Just watch this for a moment. You can select things from a list. You can type things in. You can search for stuff. It's got error handling, apparently. So potentially it might work, right? Don't know. Okay, so let's unzoom that. Let's see what other Rust crates there are. Let's see how many people use this. A few people use it. Look, quite a few people use it. 2 million downloads. That's quite a lot. Okay, so we've got some tags here. CLI, interactive, prompt, question. Let's go for interactive. WASI term, so inquires right up there on the top of the list there. That's interesting. Request UI widget base CLI. Let's search for hash CLI and hash interactive like this. Simple to use interactive. Yeah. Well, not many people use it. Sort by all-time downloads. WASM bind gen? I'm not sure about that. That doesn't look right. SQLX. Cert command Y. It's YMOC. Huh. Interesting. TUI, look, text UI. There's another one. Let's have a look at this. Now, I think we stumbled across this the other day. Oh, no, we didn't. This is a different one. This is interesting. Yeah. Immediate rendering with immediate buffers. Uh-huh. Hmm. Moreover, the library does not provide any input handling or event system. Curious. What's cross term? Let's have a look. Like evaluating packages. Cross-platform, blah, blah, blah. What can we do? Start terminal, cursor, move the cursor, input events, mouse events. What can you do with it? Cursive. This is the one that we found the other day, wasn't it? This blue one, yeah. Yeah. That is the one we found the other day. Interesting. And then TUI, that's the one we were just looking at, yeah. B-root, what's B-root? So, interesting. Interesting. I didn't even know this program existed. It looks quite handy. I'll be damned. Huh. Huh. Well, there you go. Manage files. Look at this. Oh, look, it's got tree. Oh, dear. The ASCII trees. Yay for ASCII trees. That's pretty funny. That's interesting. Okay, so it's good to look at some of the other things that use these libraries that you might possibly be using in order to find out whether, you know, like examples of what you can do with these things. So that's interesting. Rusty Sloth. What is this? Oh, you can get a. Fantastic. All right, that's pretty funny. A 3D rasterer. Really? You can do STL model loading. Why is that important? Because loads of the EDA tools use. That's actually quite funny. I can't believe I'm considering doing this. Right, here we go. Yeah, the EDA tools use STLs in the 3D model renderings. That's pretty funny. I'll be damned. I'm going to bookmark that because it's really funny. CLI 3D renderer. Okay, let's get rid of that. Yeah, let's bookmark this. Terminal file manager text. I don't like this crufty looking user interface. That's my first thought with this cursive thing. Sure, you could probably change like how it looks. Yeah, you can look themes. Cursive. Cursive. But it's got some interesting components though, widgets and things like this. Interesting. Okay. Oh well, that's no good. Curious. Huh. Very funny. Yeah. Not entirely sure about this cursive one right now. Interesting. Ah, that's interesting that they list the dependencies for it and say why. There's a lot of Unix only things. It's interesting. Interesting. Deprecated examples repository, but why is it deprecated? Is it because let's have a look at the examples for this cross-term thing. Let's try running some of these examples. All right, let's see what happens here. Okay, so let's create a new one of these. Sure. No. Yeah, that's what I want to do. Yeah, here we go. Okay, we'll copy this. Cross term. Show me the code. Let's clone this. Let's see how it goes. Okay. All right, we've got this cargo build. Let's just go cargo build and see what happens. Okay, it builds, so that's cool. So running the examples, there was a thing that said how you run it. Wait, come back. Getting started. Feature flags. I thought I saw an example thing just a moment ago. Oh, here it is. Oh, there was another README inside there. Right. So this is what we want. And then it was command line completion, interactive test. What's it called? Oh, it's called interactive demo. What? Do you have to go like /test on the end of it? How are you supposed to run this? Am I typing it in wrong? Interactive-demo. Interactive-demo. Weird. Okay, let's see if we can. Here's an example, right? But it's a bit weird. Name interactive demo. Interactive demo. This is what I want to run. No. How are you supposed to run the interactive demo? I mean, oh, it says there. Look, it says to run the interactive demo, go into the folder examples interactive demo to do cargo run. Okay, fine. I missed that. See examples. The interactive demo cargo run. It says. Let's have a look and see what we see. Available tests. Cursor. Sure. Got. I'm pressing keys. It doesn't really do anything. Hide cursor. No. What do you? I press Control C. Okay, every time I press Control C, it does something. Bit weird. Okay, color. Sure. Display attributes. Input, it says. Test. It's got down and up. And repeat. Okay, fine. No drama there. Oh, I press Q to do it. Input. Q. Any other key, continue with the next. Oh, I see. 5. Synchronized output. It's not particularly exciting, that. Okay. Should we have a quick look at some of the source for that? Let's see what it looks like. Run tests. Curious. Oh, I see. Let's have a look. Synchronized output for input. So it knows where the cursor is all the time. Interesting. Okay. So you get events and it blocks. So yeah, you got inputs and so on like that, but where's the widgets and stuff? There's no sort of widgets and stuff in here. I'm not sure about this cross-term thing. So let's have a look at the TUI stuff, and because here there's like little window thingies and there's stuff happening. Let's have a look at this. So the back end is what it uses for getting input and all that kind of stuff, right? So I'm sort of right. Right. So it's for like moving cursor and getting events and all this kind of stuff, which is fine. So what can we do with TUI then? Let's try this. Let's try this. Let's try this one. Let's try this TUI thing then. Okay. So repo. What? Is it dead? Is it dead? Ah, interesting. This crate is no longer maintained. Ratatouille. Okay, interesting. Okay, we'll bookmark that. Let's have a look at the website. There's a website. Yeah, look, so you can pick things, you can do stuff. Uh-huh, interesting. Okay. Introduction. Lightweight alternative great GUI, applications in constrained environments, inputs and events. Absolutely fine. Interesting. Examples. Widgets. Okay. Okay. Oh, that's interesting. This table one looks useful. Interesting. Build a pattern. Okay. Let's have a quick look at the table. Interesting. Oh, I've already got the git clone bit there. Let's have a look at this then. Sure. It uses that cross-term thing. Let's have a look. Wow, that's a lot of dependencies. Holy moly. Holy moly. 227 things to display an interactive table. That's a lot of dependencies, come on. So, yeah. You know, so if you can imagine this, you've got like a list of components and a reference designator, and you know, so it can show you which one you want to pick, and you can pick it, I suppose. Can you I don't know, columns and things like this? See, it seems not entirely unreasonable. What is going on with this? Wow. Let's have a look at this. Why? I mean, you've got test dependencies and then other dependencies. Let's have a look. Dev dependencies. We're not too worried about the dev dependencies, but they all still need to be able to be downloaded and built. Okay, so it's not got too many non-dev dependencies. So config if, yeah, we'll be using this at some point. Probably be using this. Probably be using this. Cross term. Either's probably, yeah, these are okay. Last recent use, that's okay. Don't know what these are. I don't know what strum is. What's strum? Let's see what that is. Yeah, evaluating like packages. Not easy. New tab. Okay, let's go. Cargo strum. Oh, the voyage of deciding what to do. Let's have a look. What is it? Set of macros and traits for working with enums and strings. Easier. Shouldn't that be more easily? It's not very good English, but never mind. Show us an example. Enum string. Yes. Yes. Yeah, some of this is probably quite useful, actually. How popular is this then? Oh, it's pretty popular. That's interesting. Okay, fine. So, you know, if its dependencies are also very popular, then that goes a long way. Oh, I just banged my foot on my chair. Oh, that hurt. Ow. Right, next thing then. So let's have a quick look at what else we got. There's some videos. This will be interesting. Cool. Okay, so it looks like there's some pretty good resources for this project though. I mean, it seems fairly good in that. Okay. Interesting. Oh, look at this. April this year, someone did this video. There's a whole series of videos. Okay. Interesting. Let's have a quick look. Is there a link to a GitHub repo? No. Damn it. Okay, well, maybe we'll come back to that. Let's give this. So my current options at the moment is this Ratatouille thing. It seems to have quite a lot of widgets and things like that. Or this inquire thing. My first thought was this inquire thing. I wonder if you can use it. I wonder if it's compatible with the other one. Let's find out. Inquire and Ratatouille. Have a look. No. Interesting. So the other Ratatouille is more of a full-blown sort of user interface, and Inquire is more, yeah, interactive prompt. Where do we want to go with this? That's the question. Where do we want to go with this? Where do we want to go with this? Are we going to go down a big, deep, long rabbit hole if we go with the more complicated solution? This Inquire looks, more simple. However, long term, we know we want a graphical user interface. I'm wondering whether using Ratatouille will allow us to structure our application in a way that might work for the graphical user interface. I don't know. It's interesting. It'd be interesting to see what happens if you try and build an application with a text user interface and a graphical user interface at the same time. Huh. Interesting. Okay, so yeah. Okay, let's go with this Ratatouille thing. Let's just go with this and see where it takes us. Right. So if we've decided that we want to use this, let's see if there's a little getting started thing. There is. Well, it's basically and waits for the user to press Q to exit. Fine. Install Rust. Yada yada. Create a new project. Yes. Okay. Fine. Right. Add the crate. Creating an application. Let's see. Yeah, okay, interesting. So we go enable raw mode, we create a new terminal and you clear it. Fine, whatever. And then you can do stuff and then, right. Panic handler to fix things when it goes wrong. Add a mainnet, draw the UI, handle the events. Sure. So we get terminal draw frame, render a widget. Seems fairly reasonable. Okay, so and then event loop here. Okay. Okay, that seems fairly reasonable. Let's have a look at our table widget and see what that looks like. Is there an example for the table widget? Repository. Examples. Table. I mean, we just ran it a minute ago, so we know there is. I want to see what the source looks like. We got some. Yeah, okay. That's interesting. That's interesting. I mean, this is sort of what we. Yeah, okay. Righto. We've got to try and work out like how we're going to do this. Are we going to do this one in one pass as it goes through? Probably. Or are we going to have some callback mechanism where it resolves it? I think the one pass and retry thing is probably going to be more appropriate so that you can get a visualization of everything that happened. Doing it the other way might sort of pigeonhole the implementation into ways that aren't necessarily compatible with doing it with some other GUI library. Excuse me. She did it in threads, I suppose. Yeah, you get into thread communicate. I don't want to go into that. No. No, don't want to go into that. So what my thought there was is that you could have one thread which basically says go, and then if it gets to a situation where it can't progress, it could potentially sort of like wait for someone to give it what it needs in order to progress. As in, so say you're in this situation where you're trying to resolve this situation, right, where you've got two of these. We've got this part mapper, and it comes along. I mean, actually, we don't actually have a way of selecting things yet because we've not tagged anything. All I've done is just display it. So if it comes along with this, and then yeah, no, I don't know. So instead of because you still need to see which ones happen. Yeah, interesting problem. So the variant builder where it prints things. Let's have a look at where it prints things. This. So you get a map of processing results at the moment, and the processing result basically may contain multiple things that were able to be mapped. And then my current display code basically just goes put brackets around the second one, but it hasn't actually really sort of selected anything. It's just display code at the moment. There's no sort of selection process in it. So we've got a mapping tree. Okay, we've got a mapping tree. Now, is the mapping tree going to contain actual selections, or do we want to go from a mapping tree to some other thing which contains like the final sort of like list of stuff that the user wants? Or do you rerun the process again? Yeah, wait a second. And then the idea is then you would have this sort of tree with like unmatched things in it, or whatever, errors and things like this in it. is okay. And then you say these are the errors, and then the user has to resolve the errors some way. And then you rerun the process again, and then eventually you'll end up with a situation where there are no errors, and then you use the results. Turn the fan on. It's toasty out here in Spain. I think we're going to go the errors route. Like selection. There's just so many different ways you could go with all this. I don't know. I think we'll probably just try building something and see what happens, and then go from there. So let's look at this. I mean, how are we going to write a test for all this? I have no idea. Writing a test for a terminal-based user interface thing. This is going to be tricky. Okay, let's see if there's any notion of tests for like widgets table. There's tests for the table. Let's see what the tests for the table widget does. Okay, this is interesting. What's RS test? Oh, I don't know. Argo RS test. What does it do? Rust fixed-based test framework. Okay. Oh well. 13 million downloads over all time. Can you do with it? Oh, yes, good. I'm glad I stumbled across this now. Okay. So what we got? Rust, RS test, fixture, parameterized. See, it's what I said last week. I want some parameterized tests for this, that, and the other, but I didn't want to go down the whole sort of process of creating parameterized tests. And now I've stumbled across this library, which is used by something else that I'm considering using. So interesting. A bit tired today. Didn't sleep that well last night. Oh. Yeah, that's good. Yeah, nice. Interesting. Very interesting. What does it create after this? I see it creates multiple. Okay. Huh. Yeah. That's very good. Okay, we'll definitely take a look at that. Right, I was trying to look at the table example. Leave. This. Okay. This is interesting. It's good to know that this Ratatouille has got a decent amount of tests for it. Yeah, I'm quite happy about that. This is very good. Okay, let's point our IDE at that thing that we just dev libraries Rust Ratatouille. Well, I'm going to say trust project, but you know, I don't trust it that much. New window. Okay. So let's see if we can run some tests. Here we go. Oh, we've got to wait for it to finish building. Yeah, we can do that. Yes. Defend the configuration. Creating indexes. Okay. All right. Come on. Here we go. No, not yet. Run all tests. It's always a good idea to try doing this. Because if you can't do it, and you can't run all the tests, and then you find something wrong with it, you're just trying to create a pull request to the project to fix it. It's not going to be a happy, fun experience. Failing test. Okay, but look at the amount of tests. Pretty good. That does seem fairly well tested. Look, 1,958 tests. That just inspires me with confidence. I wonder what the reason for failures were. Oops. Buffer content's not equal. Oh, look, there's an extra character here for some reason. Ah. I wonder if they know about that. I mean, when I check this out, I use the latest rather than... wait, no, it checked out latest version of Crate, didn't it? Git latest. Whatever the tag was. Okay. Yeah, there's just some sort of weird rendering artifact somewhere. I'm not sure what's going on with that. It's probably already fixed. Because someone somewhere is going to know about it. Curious. Okay. Okay. Let's have a look. See what else we can find. We've got examples. Let's run... Let's try running this. Is it going to work? Oh, it does work. Look at that. I'll be down. Huh? Yeah, you can pick things in a list. Look, I'm moving the cursor around. What happens if we tab over? Yeah? No? Oh, it just scrolls through the list, right? And then it moves something else around with it. Yeah, interesting. Oh, what happened there? That's weird. Why does it do that? Does it just time out after a while if you don't press anything? No. What am I doing? I just leave it? What does it do? That was weird. If you press Q, it does it. Huh. Okay. All right. Demo 2. Try this one. So yeah, it's just sort of, yeah, okay. Well, not the greatest example. Still. VHS. What's this about? What's this? Okay, well, there's lots of learning going on today. Let's have, what's this? What is it? Go. What? Write terminal gifs as code. What? 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 Oh, I see. Right, so this will create like some random little files or whatever, which will probably be used somewhere. Is that one thing? GIF. Oops. I don't think I was going to press it there. Huh? Okay. You seems fairly reasonable at the moment. All right, that's one of these things. Yeah, fine. Then we looked at this one a moment ago, didn't we? Yeah. Yeah. User input. Let's have a look at this. Because there's selecting things and there's asking for mappings and so on. What does it do? Oh, it's because I'm moving my mouse and it's doing funny things. Oops. Boo. Bar. That's interesting that it moving the mouse over the window causes input to occur. Is there a... Is there a mouse example or something? Minimal? Huh. Oops. Let's have a look at this. Right. Right. Okay. So there's stuff to do with testing how all the widgets are rendered, right? Okay. But that requires access to this. But if you're writing how do we write a test for this? How do we write a test for it? Do we? How do we simulate the user input, for instance? Like, how do we make sure that the... Yeah. I don't know. I don't know. I don't know right now. So I don't really care about the widget test. I want to know what the approach can be to write tests for a Ratatouille based thing. Let's see if there's anything on their website regarding this. Ratatouille, it's they had a website, didn't they? This. No. No. Back to this. Was there a website? This one. I wonder if they have a Discord server where you can ask people. Let's see if we can find it first, though. It's got layouts. That's good. Huh. Okay, don't really care about that right now. Application patterns. Let's have a look. Let's see what this says. Yeah. Okay, fine. So it's similar to that. There's a word I've never seen before. What? Curious. I'm not even going to try and say that word. Right. Why didn't you just say teaching? Why have you got to be... Okay, fine. Okay, fine. But you know, 50 years old and never seen that word before. Maybe I don't read enough. I don't know. So, yeah, pretty standard stuff. Yeah. I didn't know you could do that. How are we going to do this? How are we going to do it? Okay, this is interesting. Key feature of tier is immutability. The update should avoid direct mutation of the model, instead produce a new instance of the model reflecting the desired changes. Okay. Crucial to maintain a clear separation between the data model and the logic that alters it. Yes, perfect. Yep. Mm-hmm. Mm-hmm. Let's have a look. But wait, I thought it just said that. I thought it said it shouldn't be mutable. Wait, while immutability is emphasized in tier, Rust developers choose the most suitable approach based on performance and application needs. For example, it's perfectly valid to do the following. Curious. Uh-huh. Yes, just reading through this documentation. Yeah. Does seem pretty comprehensive. This got some pretty good documentation, which is good if you want other people to be able to contribute to it, because you can point them at the documentation that you read in order to came up what you came up with in the first place. Uh-huh. All right. How do we write a test for it? So you could write tests for the individual bits of like message processing and all this kind of stuff, but how do you say, yeah, how do you write a test that like runs it, waits for it to show you what the problems are, and then let you choose what you need to choose, make the appropriate selections in the user interface, and then say go? How can we write a test for that? It's almost like you need to look at the terminal output, wait for it to contain certain phrases. But what if that phrase appears multiple points? Yeah, okay. So looking for snippets in the text output might be a workable way of doing it, which is, how you test sort of web apps and stuff with Selenium, right? Things like that. You say, wait for this to be displayed. But Selenium runs in the browser and it looks for certain sort of CSS tags and so on like that to identify things, right? But with this, we've got a terminal and there's no sort of, at least I don't think there is. I don't think the test code is going to have access to the terminal, and the terminal is the thing that's going to be displaying the stuff. Unless the tests, you can have a sort of weird instance of this terminal that you can interrogate and or have it generate messages when some things happen. So this TGY says it uses like a backend, terminal backend, right? So if you had a different terminal backend, what does the API look like for a terminal backend to use with Ratatouille? Because it says it can use crosstalk and it says it can use another one, right? That's what it says. What does it say? Other backends, termi and termwiz. Yeah. How do you test your app? I want a functional test for my app. That's what I want. Okay, let's switch back to this. And let's see if we can work out things, people going on outside the front of my house. Okay. So terminal backend. Here we are. Look, backend. I missed it. Okay. Look, test. Someone's already thought of this. Fantastic. Let's have a look. This module provides a test backend. This is what we want. Backend information used for integration testing. Yes, 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 yes. Yes, this backend is intended for integration tests that test the entire terminal UI. Okay, fine. That's what we want. So how can we find an example? No, that's not sort of what I want. It's not quite what. I don't want tests where I'm drawing the entire application inside. Uh, hmm. Hmm. It's almost like you want a list of things that happened in it and the order that they happened in it, right? In it. So, for instance, you say the terminal should be initialized, the screen should be cleared, a box is drawn. I don't know whether you've got the option to do that. But let's have a quick look at the widget again, the table widget, see how it interacts with the terminal. So creating rows and all this kind of stuff, that's all fine. Right, but how does it do it? Where does it do the rendering? Let's look for the structure. Structure. Man, it's a bit smaller. There we go. Bigger. Right. Table. See, it's just going to have like a render. And then it asks cells to render. Yeah. And let's look for render in the cell. Just do that here. Wow. Yeah. It's not really going to be any way to sort of intercept all these things to find out what's going on. GUI testing is really difficult. Whether it's text-based or whatever. I guess perhaps what we could do... Perhaps what we could do is ignore the fact that a GUI even exists, right? And then as part of our application, we create events, like a log of when things happen, right? So for instance, you say run the application and use this file to, or this pipe or something, to write events to as things happen. Right? You run the application and it goes, okay, I'm loading this stuff from this file, yada yada, and an event happens and it's got a message in it, right? Like a trace log. And then it displays the GUI and it says, I'm displaying the GUI and an event creates it. And then it presents the user with like a dialog for choosing a part mapping, right? So it writes to the event log, creating dialog for part mapping, yada. And we can test that the sequence of events happens in the right order. And we don't even care about the GUI library itself. That's probably not a bad approach. Now, if you remember from one of my earlier streams, what I said was any architecture that allows you to defer making decisions until a later date is a good architecture. Why is that applicable today? If we decide that we don't like this TUI thing, and we end up wanting to use Inquire instead, right? How we've written our test, it's a test that says, get the user to choose something, won't actually change if it's looking at an event log in order to work out what happened. Right? This probably is a fairly sane thing to start doing, I think. Okay. I think I'm sold on that idea. Right. I'm going to ponder this for a little bit. I think I need a coffee. So I'm going to be back in a few minutes. All right. So go and get your coffee. Have a little think about things as well, and I'll join you back here shortly. All right, welcome back. I've got my coffee in my favourite mug. I've got some bee juice in it, honey. Bee juice. All right, nice. Happy days. That's pretty tasty coffee. Nice. If anyone's watching this and they enjoy it, don't forget to click the subscribe and Patreon-y things and stuff like this so that I can afford more coffee and things like that to keep me going. So any support, no matter how small it is greatly appreciated. Because I don't know when I'm going to be able to sell something to anybody at some point to put put a roof over my head. Because my pick and place machine ain't working, in it. I can't build my things. So yeah, in the meantime, righto. So right. So while I was downstairs getting my coffee, it's always good to step away from the screen every now and again while you're doing all this decision stuff. I had a couple of thoughts. One, the amount of stuff that you have to do before you even write a single line of code is ridiculous, as this live stream is attests to. Rather. How long have we been going so far? Let's have a look. Where's the little timer? An hour and a half. I've not written a single line of code yet. That's just nuts. Like, that's nuts. I don't think a lot of people that look at a code base have an appreciation of the amount of time that you have to spend doing some random things, like before you even write a single line of code. Yeah. Interesting, no? Right, so that was thought number one. Thought number two was that this approach to testing this little command line tool and all this kind of stuff, the idea of testing for events and so on like that, for testing it at a functional perspective, will work for a text-based user interface, command line sort of text interface. It should also work for a graphical user interface as well. The other thing I was thinking was that it's quite possible that the separation of like events and data model and all this kind of stuff is probably very similar for other GUIs based on the Elm sort of architecture, as it were, such as eGUI. I'm just wondering whether to look at eGUI really quickly now or to just go, no, that's enough learning for today. Yes. Okay. So let's look at our test for a moment. Let's try and work out what we even want to do. So okay, let me show you guys a little bit more about the test, right, and how this situation even occurred, because this wasn't in yesterday's stream where we added the second resistor. So what we've done at the top, and there were some other refactorings that happened to make life a little bit more pleasant. What we've said is that you've got some placements and there's a resistor and another resistor, and they both use the same. They both have the same specification. But then we said we're going to create an assembly variant where we don't place R2 on the board. We only place R1, right? So we need a part mapping that goes from this name and value to a component that's made by some manufacturer. So in our list of parts, we define two parts, two resistors, one from manufacturer 1 called resistor 1, and another one from manufacturer 2 called resistor 2. And then we're saying our part mappings, and this is the bit that wasn't in, this is the important bit that wasn't in the stream yesterday. We say create part mappings and a mapping for a resistor. right? So we have the same name and value, and we say this resistor from this manufacturer is applicable to this specification here, right? And then we have an alternate mapping for the same specification, as in we say we've got, if we see a dip trace EDA placement with a resistor value of this and another value of this, the same as we've got here, this one can be used, right? But somehow the user or the system has to decide which one of those to use. So what we want to do right now is ask the user which one to select. Right. So that's what we need to do. But do we? I mean, eventually we do. Okay. So when we're going through the list, we could present to the user a question every time there was a choice that could be made. But I don't think that's the right approach. I think what we need to do is present to the user a list of problems that they need to fix. And then our test just needs to record the fact that the user was able to resolve these problems in whatever order they desire. They don't necessarily have to resolve the mapping issue that there is between the first resistor's part selection. They could choose to do the connector first and then do the resistor. It doesn't matter. Just as long as they did both and then said go, and then the expected output was created with the mappings that they chose. So we know that we want this, right? But we also sort of want something else as well. Now, this list here, interestingly enough, is actually sort of like an event list already, isn't it? Let's look at it. So, we said run the tool and something happened, and then run the tool and then this thing happened, right? So these, and these, we're just dumping these as printlns to standard output at the moment. So imagine, if you will, that instead of these things appearing on standard out, I mean, they could appear on standard out, that they were also logged to some log. So you run the program and some stuff happens. It maybe prints things out on screen, and it also writes to the log file about what it's doing and when it did it. And imagine that our test was able to read that log as it was being written to. So we need some inter-process communication-y thing. So it's either a file or a pipe or something like this. We can decide how we're going to do that in a bit. We've got to look into options for it. So we can look at that and then check that log contains the things, and we will be able to, and we're not doing this at the moment, we'll be able to check the order that these things happened in. So if you remember from previous streams, I did mention that our test doesn't care about the order of these things. We can move these around and the test will still pass. Right? But this list currently is the order that things happen in. But we don't necessarily, but there's nothing that enforces that. That's what I'm trying to say. So we could sort of rewrite this a little bit to enforce the order. Yes, and then we've got all this tree stuff as well. Hmm. Yeah, so we could still check the tree, the before and after kind of thing. That would be okay still. Du- 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 du. So, so, um, how can we get? So what I'm trying to think is how can we get the test to look at a stream? So I think that's what we do to start with. We'll poke this test into looking for events. Let's see if we can make some progress on that. I need faster fan, less hair. Yes. Right. Let's fix. Let's fix this. It's hot. It's very hot. Right. Okay. So let's see. So we've had this nice long investigation about what GUI libraries to use or text user interfaces and things like this to use. Uh, Now it looks like we're going to need another investigation to work out how we can send events from an integration test, or send events to an integration test and then have the integration test look at them. Okay. Yes, fine. Now I'm trying to think of the terminology that I would use to search for this. It also seems like I forgot to click this button here. Yes. Let me just go back over what I was just talking at because you couldn't see it. Yeah, this list was the events, and I was saying that you could reorder these, and everything would still pass. But we want to enforce the order of these somehow. Right. Okay. Okay. Let's see if we can find it. So what are we doing here? We're yeah. Okay. Let me move this to a new window. Okay. More crate searching. So let's search for pipe. Well, synchronous read-write memory pipe. Yeah, okay. Pipe watcher, pipe. Read and write for the terminal. The terminal? No one uses that. Let's have a look at this. Wow. Well, this is dead. And no one uses it. So not that. Probably not that. Not relevance. All-time downloads. Mio, look. Wow. Generic extension for tapping values. What does this do? Async process. Curious. And Mio. Yeah, I don't think that's what we want. No. Curious. Typed. Hmm. Hmm. I mean, is there already an API for dealing with pipes? Let's just look. It's stored on pipes. Child processes pipes. Yeah. Can we create a new pipe is what I'm thinking. Do I want to create a new pipe? I don't know. Curious. Okay. uh, I mean, we could add some. Let's search for event pipe, maybe. Event bridge. Let's have a look at this. What's this? Event bridge. Curious, but maybe that's a bridge. How to find it? Ooh, what does this do? Observability framework and toolkit designed to create and manage telemetry such as traces, moves, metrics, and logs. Interesting. Focus on the generation, collection, management, export of telemetry. Okay, interesting. Okay, tracing API. Logs bridge API. That's a bridge existing log management open telemetry line. It's not meant for use to call it. Let's have a look at this tracing API. It looks interesting. Tracing. I suppose that's what we're doing. How can you do it? Yes, this kind of thing. Okay, is there an example of this? It looks quite big, but oh, wait, where's the? Oh, this is the specification. Wait a minute. 74 repos. Oh my god. Just wow. Okay, well, damn, there's a lot of code. Damn. Uh, okay. Okay, let's open telemetry. Open telemetry Rust. Examples. Log appender, yeah. Metrics. Tracing. Talking. Have a look. Interesting. Interesting. Log provider. Build a log. Where does it go? Open telemetry log bridge. Right, so you can log stuff using open telemetry. There's a sort of defined way of logging stuff. So open telemetry stood out. What? But open telemetry append a log. Look at this. Tracing crate. Bridging tracing logs into open telemetry tracing. So it's the other way. Okay. Let's have a look at one of these. Seems fairly heavyweight, but perhaps and quite comprehensive. I mean, the way you use it is okay, and there's some other stuff to set it up which is okay. It doesn't seem too bad. But how do you attach to a log? This is what I want to know. How can self-diagnosis? What's this? What does it do? Hmm. Appendo. How do you? I don't know. Like I'm only seeing one side of the system. Like you've got a logger, but then you've got a reader. Where's the reader? Search for open telemetry read log. Just okay. Look at this. What is this? No. No. This is all collect. You need a collector. Okay, back to the open telemetry. Uh, Collector, yeah. I'm curious. Okay. How? Wow, that's a lot of stuff. What is a meter provider? No. No. Not sure if this open telemetry thing is what we want really for this. I think we need something a bit more lightweight. I might be wrong. Probably am, you know. But again, I look back on this and go, "No, you should have picked it." Let's look for streams instead of bridge. Streams. Relevance. Let's look for Rust Tokyo and see if there's. I'm not sure this is what we want, but yeah, channels, isn't it? Yeah, but that's in the same process. Though. You see, we've got two separate processes. We've got the test code, you know, the binary that we're trying to run, and then we've got our integration test. And it is sort of like a channel, but over. Yeah. Okay. Let's look for a channel. What is no channel? Crossbeam, yeah. This I've come across this one before for some reason. Channels, yeah, but you know, is it in the same thing? What's be vomit? I just saw you seeing your thing, Darkman. That's hilarious. Yeah. Okay, so let's search for Rust interprocess. Few things. Yeah. Sending and receiving small message between various executing processes of the same application. Monitoring control posts. Exactly, yes. ZMQ. Okay. Universal messaging thingamajigamy. Okay. Let's have a look. What can you do with it? Well, what is it? Into process, yeah. More, yay. Joy of joy. Huh? I don't really want to go. Oh, I don't like it. I suppose we are going to have to use the operating system for this at some point. I mean, don't necessarily want a library like this to do it. Yeah, not sure. Not sure about that. Let's have a look at a different one. 2.2. Well, I mean, that's good. Create style. Yeah. What can you do with it? Okay. Unnamed pipes. Anonymous file-like objects for communicating privately in one direction. Child process and its parent. One direction. That's sort of what we want, isn't it? We don't need to go both ways. Mm-hmm. Mm-hmm. Let's have a look. Samples. Unnamed pipe. What does this do? So you create, but we don't really care too much about the implementation of the thing that allows us to get messages from one place to another. We just want something that can do it to start with. Wait a second. So you need to get the handle of this unnamed pipe from the thing that creates the unnamed pipe. And then you've got to pass that how can you do that if we're running like manned? Like it's just a completely separate operating system process rather than like a thread. In our gosh. Am I thinking about this the wrong way? Do I actually need to? Yeah, I probably am. Oh, this is probably what I'm thinking. I was thinking that our test needs to be able, yeah, no, it needs to be able to receive these events as they occur, but they don't. It doesn't, does it? It just needs to look at the events that happened after they all happened. I don't need any of this. I don't need any of this. I don't need any of this. Okay, fine. Let's get rid of this. No, I was thinking about it wrong. So, what we're going to do is add a new argument, which is --trace equals some file. And then when you specify that, it's going to write stuff to a trace log, and then we're going to look at the trace log that was produced. Fine. Yeah. Okay, fine. So, you know, this is what we're trying to do, but we can't do it yet. Let's go. Oh, yeah. This will be good. We're going to do this. Here we go. Part arg is like this. Oops. Fuck, I'm writing code. Oh my god. How many 2 hours and 12 minutes of not writing code, and now I'm writing code. So we're gonna go test trace. Yeah. Right, I made this little thing the other day. Build a file. And we're gonna say log. Sure. Trace. We're going to go trace log. Yay. Yeah. Sure. And then we're going to do the whole argument building thing. We're going to say trace. And we're going to say test this thing. Sure. Okay. We're going to prefix this with an underscore because we don't use it. Right. But it's not a part mapping arg. That's wrong. This is a trace log arg. Sure. And we're going to put it as the last thing, I think. Trace log arg as stir. Right. Then what we're going to do we're going to change these assertions here. So we need to read and file somehow. And this predicate stir thing. Right, so let's have a quick look at this. It stood out. So what does this do? It takes cell and some predicates. Assert. So, okay. So what we want to do is assert on some files or something, really, using the same predicates that we were using before. How can we do that? This is an assert command. Someone else will have already done all this stuff. Yeah, let's have a little search for this. Rust assert file content using predicates. There's probably an example in the predicates crate. Assert fs. Okay, cool. Oh, I don't want that. Okay. Okay. Assert fs. Let's have a look. Uh-huh. Where does it come from? Oh. Have a look. File system fixes and yes, okay. So assert, yeah, this is what we want to look. Perfect. Perfect. Let's add it. Assert for. Okay. This is great. See, you can pretty much guarantee that with Rust, the thing that you're trying to do, someone else has already done. There's a good crate there waiting for you to use. This is great. Just like integration. Dependencies, dev dependencies. Yeah, it's a dev dependency, isn't it? It's going to be assert fuss. I'm going to say version is the latest one. Go. Okay, cool. So instead of doing this, yeah, no, we're going to need this now. Good. Okay. So we're going to try moving these around. We're going to go assert fuzz. I think I might need to press refresh on my cargo thing, but normally it does it automatically. Let's go refresh. What can we do here? Trivial example. It says assert a fuzz. Yeah, but we've already. I want to create. I've already got the file. How do we create a new thing to assert from? Didn't quite work it out from that. Let's see. Named temp file, probably. New, this thing. Okay, and then perhaps we steal these predicates like this. We completely get rid of the assertions on standard out, which we might have to revisit. But we actually don't care about the standard out, and we're going to change what the tool does with the standard out anyway to use some text user interfacing. And we're going to say that the trace log. How are you supposed to do it? Just go trace log. Is it just assert dot assert? Yeah, it is like this. I need another bracket. There we go. Why do you have to? Do I have to import the trait? Yeah. Probably that. Let's have a quick look at this. Prelude, yeah, predicates, prelude, fine. Okay, so we're going to do that. Right, does it compile? It should do. I mean, the thing that we're passing over to this might be the wrong. Couldn't convert it to error. Why? Stood IO error. We say that we're returning this, but it returned us what? Just gonna do that for a moment. This probably is wrong. Okay. Fine. So okay, fine. Fine. So obviously this is not going to pass because nothing's creating the trace log, right? And it's all been printed to standard output. So this is our first step that we can do. And it would say, don't know what you're talking about. What's this argument that you've given me? Those are the tabs. So we go back to the bin. We go back to our opt. We go back to our commands. Here we go, placements. Now this option is more general. So yeah. I can't remember all the things. So we're just gonna copy this for a moment and just schlep it in here. Trace log. Trace log. Sure. Trace. Right. So hopefully it'll understand that. But let's see what it says here. So we've got our test that says like this, but there's going to be some like more options and stuff now. Right, here we are, look. This is what we want. This is good. That comes above this. Goes here. Yeah. Okay. Now it also changed the indentation of the other things. So they're probably going to be about there. Let's see how close I got. Nope. Was so close. And option. Oh, it's got options here now. Yeah, that makes sense. Okay, good. And this now says unexpected argument dash dash trace found. But why? But we just added it. It's probably because of the placement of the argument in the thing. Let's move it up. Because it's an option for the program. So now, there we go. So now it accepted the argument, the option argument. There we go. Didn't do anything with it. Completely ignored it. And then when our test tried to open a file, it went no. Okay, so let's make it log these things to that. How can we do it? Oh, dear. So, are we going to use existing Rust macros, I suppose, is the first question. Or are we going to roll our own trace logging? I don't think I really want to roll our own trace logging. I think that's probably a bad idea. Tracing. Not sure about that. This wasn't what I thought, but this is interesting. Let's Oh, that's interesting. Look, tracing with open telemetry. Yeah. This is the kind of stuff that we need to do. How we need to. Is this what we want to do? That's interesting. That seems fairly unobtrusive. But where does it go? But where does the interesting? Yeah, we've got the. Yeah, logger, env logger. Hmm. So we've got tracing, env logger, or log. Hmm. I don't really want to follow these Java pattern thingy. Yeah, it's more like tracing than used to record the flow of execution through a program, which is what we're trying to do. Spans. Yes. Yes, that's sort of what we want to do, isn't it? I think tracing's the right one then for us. Because it's not just an arbitrary event. It's like you say, I'm starting to do this, and then within inside that thing, something happened. Yeah, so inside like some part resolving process or, whatever, some stuff happened. Yeah, okay. Okay, well, let's try this tracing crate then. how do we get it to log stuff to our tracing thing? Here we go. Create file. Right. Let's just use this and see what happens. Sure. Okay, fine. Tracing, here we go. Okay, so we're going to say trace. Oh my gosh. Well, that's interesting. Does feel like this. Well, that's interesting. Oh, no. Don't do that. Let's look for an example of this. Rust crate tracing. Is this the right thing to do and to look at? Yeah, are we looking at the right one? Yeah. One. Tracing. Application level tracing. Yeah, this tracing framework. Yeah. Instrumenting Rust. Yes. Yes. So we go. Executables have to use a subscriber implementation compatible with tracing. Subscriber implements a way of collecting trace data, such as by logging it, stand out fine. So we need this tracing subscriber as well. Oops. Missing an equals. Oh, just got brackets everywhere. Okay, fine. Then we're gonna refresh. Okay. Format subscriber builder, but how do you say you want to write it to a? Where does it go? Probably you can say a file somewhere. Good Lord. Okay. Let's go back to this. Okay, let's try this. So we're going to pass some options, and then we're going to do this. Right. But it says everything will be written to standard out, which isn't what we want. What else can we do? With file, this is what we want. Okay, and then what we need is well, I don't know. Well, let's say let trace file is opt.trace. Is that right? Wait a second. Let's just see what the compiler says about this. Because of the macro with this, you don't. It's not a method. It's ops.trace like this. That's why. Okay. And it says, but it found a string. So if we say string here, should this be a path buff? Can we make it do that? Oh, we have to go. Why does it think? This is not what I thought it did. Okay, so we can have a writer. Let's have a look at this. That's the make writer that the subscriber being built to will use to write events to. This is good. Use standard error. So it's just we need a writer. So that's okay. So I think we're right. We're going to go trace. Trace file. We're trying to open the trace thing. Can we just go whatever? And may we hope that file implements writer? Oh, we don't know. Do we want to open it? Yeah, no, we don't want to do that. Create. Let's try that. Okay, I mean, that compiled. That's good. Okay, good. Progress. And then we're going to say, yeah, we're going to use this. That's the global one. It's fine. Everything's fine. Right. The fact that, this might not exist, we'll worry about that in a bit. And then we want to go don't know what we want to go. Trace. Whatever. Now this, where do we import it? What happened? I mean, this info is from tracing, right? And we've got trace, which comes from tracing. So there's a chance it might work. There's a chance it might work. And then at the end of the program, it just finishes. Okay, let's just run this. Let's run this, see what happens. Does it open a file? Okay, okay. Look, it did. Oh, we traced something. Yeah. Whatever. Right. We traced something. That's good. 2 hours and 45 minutes, and we've written to a trace log. We made some decisions though. That's half the battle. So now we can log things, and you know it's fine. But there's this whole span concept that we're just completely and utterly ignoring right now. Let's have a look at this again. So we use set global default with the subscriber. Okay, so you can have multiple different tracing things. And you can run a bit of code with a different thingy, which is fine. Change fine. Libraries. Where's this span thing disappeared to? Span. This creates a new event outside of any spans. What does this do? So we need to know how to use these spans. Shave. Enters a span every time the instrumenting function is called. This seems pretty handy, that does. It automatically does it. That's magic. Okay, cool. Yeah, we like that. So let's have a look at this. If on this building assembly thing, we stick this here, and instead of going println, we go info. Right? Oh, this is going to be good. This is in. Yeah, I probably could have selected quite a few. Oh, look, and this is the yeah. This is actually trace stuff. That's good. This is okay. And then we've got some to-dos somewhere. This. Here we go. We're just going to say trace. And we're going to flap that there. Happy days. Oh. To done. Yeah. That one. That one. This one. Here's one. See, this is great. Import. 3 to-dos to done. That's good. Let's run it. See what happens. Oh, missing an import. Why didn't you guys tell me? Assembly variant doesn't implement debug. Assembly variant R. Wait a minute. Interesting. Okay, so this instrument thing is more powerful than generated span. Yeah. Okay. This is cool. People have done some good work here. Yeah. Skip non-debug. I mean, is that what you want? Interesting. This is interesting. We can tidy up all this sort of like instrumentation, sort of like log output and all this kind of stuff as things progress. But it looks pretty comprehensive. So everywhere that you use this, you've got to make sure that the things implement debug, which seems fine. Okay. Seems fine for now. We'll see what it comes up with. It's perhaps. Did you see that? Oh my god. Nah. Nah. Look, we logged stuff and everything. Look, we got a trace log and everything. Brilliant. Okay, let's just go. I don't know whether I'm going to be able to do this or not. I'm going to just try it. To stir. And then I'm going to just go println from the test the entire log. Now it might be moved. Okay. Okay, fine. What doesn't? Oh. Right, we know the file exists because it would have failed somewhere else earlier if it didn't. Now, this asserter will have read the contents of the file, and now I'm trying to do that again. So I might have to sort of reopen the file or reset it to the start of the file. But let's see what it printed. I wasn't expecting that. Oh, I see. Right. Let's do that slightly differently then. Let's go. Let's drop trace log. Oh yeah. Okay, and then let's reopen it. So we're going to go. It's something like file open this thing dot I just want a file. Read to string. And this is it use of moved thing right now? Yeah. Excellent path dot clone. Type annotations needed. Yeah, well, you didn't. Okay. I'm a Rust noob. Rust read file to string. Go. FS read to. What happened there? Can we not do that? I think I pressed the wrong key. FS. Sure. Sure. But the path needs to be this thing. Whatever. And then we print trace content. Fine. There's already a nice happy little thing. We don't need this import. Okay, run it again. Let's see what happens. Well, it didn't crash. There we go. Look, so now we can see our trace output with colors. Wow. Okay, cool. Yeah, this is what we want, isn't it? So we've got mapping tree, and then we've got the stuff. Okay. Let's have a quick look at what the dependency situation looks like for the project now. Cargo tree. Okay, so we're reusing predicates. Got tracing and tracing subscriber. Okay, yeah. Yeah, that's pretty reasonable so far. Okay, let's go. Let's run everything. Because I think I'm coming up on my lunch. My lunch break is going to happen. Yeah, probably do a bit more later this afternoon. Because at the moment we've just got this. I want to get started on this UI side of things. But the approach to doing the UI is now testable. That is very important. So why are we doing all this again? Let's just recap. Why on earth did we do this? What was right? Everything was printed in standard output and it was fine, wasn't it? No. Um, we've definitely broken some things here. Like what happens if you try and run the tool without passing the trace argument now? It's probably going to get very unhappy. To find out what happens, let's just not pass the argument and run the test again and see how it dies a horrible death. Well, that was interesting. I mean, was the file not found because the program crashed and that was that? Um, what is interesting about this, though, is where it failed in the test. Because we've got an assert that the command succeeded. Command succeeded. How is that possible? How's that possible? Because we say ops.trace. Wait. Where's my ops gone? How is it possible that it succeeded if the argument is, oh no, it has a default? That's why it worked. Right. Right, it has a default. Which is not right. um, should this not be an option of path buff? As in, if you specify dash dash trace, it does trace logging. And if you don't specify the file that it's going to log to, it should use trace.log as the default. But if you don't have the argument at all, then it shouldn't die. I think that's where we're going wrong. Let's run everything again. Mismatch types, yes. Right. So exactly. I'm gonna get rid of this. So What do we do here? Right, so we know that this is what we get back, right? And then I suppose we go match trace path. Some path. And if we've got that, then we need to do all this stuff, right? But the problem is, if we create this subscriber here, set global default. If we haven't done this, does it break it, or is there just a default anyway? There should be, right? And we don't really need this match thing. So let's go if let some path is opt dot trace. Then do this. Right? What does that work? It might work. Okay. Right. What does it say now? What's interesting to me is that this didn't change. Like, that's interesting. Because we added option to the opts, right? It didn't change. It didn't change. Don't know whether we need this, but okay, let's put this arg back in and just make sure the test still passes. Which it does. So all our trace logging is still fine. But I kind of want to know what happens. Let's go. Now, if you remember, we had this stood out, blah, 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 blah. Let's just say stood out. And then we had this predicate diff, was it? We were using once before? Diff? Oh dear. Yeah, here we go. Predicate stir diff. Predicate stir diff. What are you supposed to do? How are you supposed to use it? I forget. Right. Okay. So we'll just do this. Predicate stir diff. And we go whatever. I don't care. And then we can see what standard out actually contains in the test without having to like start copying files around, all this kind of stuff. Right, let's see what it says. So standard out was empty. Let's also check stood error. Standard out is nothing. Standard error is nothing. But it succeeded. Right. That's not really any good. Wait, hold on. I've got to put this back. That's what we're trying to work out. It's like what gets printed. Stood out, stood error. Because there's basically no printlns, no nothing right now. Is that okay? Not really. Right now you're on the tool, you can't see anything. So we've got tracing, and then we've got sort of like end user fancy stuff, end user display stuff. Let me look at my production code. Not that. We say with max level, so you go subscribe, you set people subscribe. Yeah. Let's make this return something. I'm thinking that we should always create a subscriber, and that the one that we're using to log stuff, is to do trace logging is like normally this one, right, with timestamps and everything like this, right? And then if you don't specify the trace argument, it still creates a subscriber which still logs stuff, but it logs the standard out with an info level. Who thinks that's a good idea? Probably not totes hideous. So if we reorganize this a little bit, let sub driver is match ops trace. And then if you've got some power, then do all this. And then return the subscriber to that. And if you don't have that, then you do something else. And then after that's all done, you use the subscriber. It needs a semicolon. But we need to return a subscriber here. So let's just make a new subscriber that doesn't log it to a file, that has info level, and return that. What's it moaning? No. Stood out subscriber logging file subscriber. Yeah. See, naming the local variables. You see, I could have just called that and returned it, but now we've got something useful here. So why is this complaining? What? Why? Oh, I see. Because this is a different type. Yeah. Okay. So if you create a subscriber like this builder gives you a different type of subscriber, which you then can't assign to the same thing because all the match arms need to return the same type of thing. There's probably a less naive way of doing this. Um, Not really happy about it. We can come back to this. We can come back to and refactor this at some point. We're going to save file. Refactor, introduce constant. We're going to put it in here, yes. We're going to go whatever, because I don't know what it is. And we're going to use it here as well. Normally when you do that, it says, do you want to replace all occurrences? But it didn't. Subscriber failed. Yeah, something like that. You know. But now we don't want this because it doesn't return anything. Okay. And let's extract that to a method. Oh. Why? Sure. You know. I don't see why it couldn't do this for me. It's like bots. Uh, and then we're just going to just move this to. I don't know why it was moaning about that. But it should be okay. Oh, cannot move. That's right. Yes. A reference to a path, but everything's fine. Yeah, it's fine. Fine. And then let's just say go. Go. And we'll be using a function. Right, so this needs to be able to return the same thing. It needs to return okay at the end. I suppose we have to go like this. We don't care. We don't care. It just does stuff. Rebounds. It's not satisfied. Why? Oh, it's supposed to be anyhow result. We probably could use that bail thing. bum, 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 do, 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 do. Oh yeah. Why did I do that wrong? There we go. Right, that's what I missed. Okay. A different kind of result object, isn't it? Right, so we're good. Right, fine, run, go. Okay. Now. Yeah. What do we do here? Well, didn't do what I thought it was going to do. And it pains me to do printless, like go whatever. No. Stood out. So let's do this and see what happens. Do we see this in the output? No. Why? Not really expecting that. Cargo clean. 3,380 files, 841 meg. Oh my god. That's a lot of intermediate files, no? But what? Okay. I'm going to get rid of these at some point, but let's just make sure we're even getting this far because it's being a bit weird right now. Is something else going on that I'm not sure about? That is the parsing of the options failing? Okay, it says using file subscriber, but why? When we haven't passed this, is it because my understanding of the default? It probably is my understanding of this. Okay, let's go back to this. So this opts thing here. I think we need to specify like args1 or something. Num arg1. I think that's what we need to do. Num args is 1. Maybe. Okay, let's see what it does now. Come on now. Come on now. Okay, now it says using file subscriber still. And this hasn't changed either. Like, okay, I'm getting very confused with this now. Let's do it. I already know what this is gonna say, but use it. Why? it has a default like this. How do we get it to say if you specify dash dash trace, but without specifying the trace file, then you get this one? Okay, we need to look at clap. Clap optional, just optional. Optional arguments that don't require values. Yeah. Default missing value. Okay. Using the wrong thing. Default missing value. Let's try that. Good, it changed the no args thing. Let's see what the no args thing says now. So now what? I find the diff a little bit hard to read. But now it says okay. Value for the argument. When the flag is present, no value is specified. Yes. This configuration often needs to give the user a shortcut to allow them to efficiently specify an optional argument without requiring a value. Equal. Let's so we go back to this. No, no, no. No. I did the wrong one. Supposed to be like that. Equal require equals true. I mean, let's try this. 3.5 hours of fun today. Expected a comma. Expected a comma. Oh, it's supposed to be equals. Is it equals one? Is it? Did I get it the right way around? No. What about now? I'm arranged syntax the wrong way around. Let's see what this says now. Okay, now this is back now. That's what I want, I think. Wait, is it? Oh. Okay, right. Yes. But it's still not showing what the default value would be if you don't specify it. You know, why doesn't it show this bit? I kind of want it to show that bit. But it's not really a default. It's like, I don't know. Okay, what happened here then? Now it's using the standard out. Yes, look, we've got standard output now. This is good. This is good. So we know the argument's working now. So that's good. So let's run this again. And we probably need some more tests around this trace log argument, really. Well, I guess we sort of have it, really, don't we? Oh, I've got the equals in the wrong place. That's fine. Yeah, right. So now that should pass, but the other one should fail. Come on. Right, good. Now this one, the standard out now contains a whole bunch of stuff. But it contains like loads of messages. Wow. You know, but this is what we wanted to print out. But it's printing out like the arguments and the what is it printing out? Part mapping source. Well, let me see. It's printed out the span as well. Yeah, you see, I'm not really sure. Not 100% sure what we should be doing here. Like, should we be doing some other things here? Let's go. Let's see what we can do. Dot. Yeah, is this? Oh, I see. So you can make it so it doesn't display the level and all this kind of stuff. So let's say with level false, with the line number false, with span events false. Oh, we got a kind. Format span. None. Right. Format span none. Okay, let's run that and see what that gives us. Because I'm wondering whether I can reuse the same predicate to check the trace logging as well as the standard output. Okay, let's see what it did. So the standard out now contains a timestamp with time. Okay, without time. Sure. But it's still got all this stuff here. Can we not just create a format which is literally just this bit? Can we go with... I don't know. Let's... Right, hold on. Let's make the test print standard out of the tool, because all the ANSI stuff is sort of getting in the way a little bit. So like we're doing, yeah, but you can't. You can't get to it. What if you go predicate stir I wanna is match. We've got a regex. No. Function. Boom. I don't know. Right. So what are we supposed to return here with this function thing? We're supposed to... Yeah. Sort of what I was thinking of. Yeah, so if we just return true here, right, everything's fine. So before that, we should be able to go println foo. Like this. So that we can see it in all its ASCII color glory. But you know, this is all learning, so everything's fine. So yeah, not really what I was expecting it to do. Can we put a breakpoint on it? Oh. I mean, yes, but you have to run it in debug mode. Okay, we'll try that again. Oh dear. Come on now. What does it do? Why do we get a panic straight away? Why? I wasn't really expecting that. Hmm. Oh. Well. Hmm. Hmm. That's most unexpected. That's most unexpected. I thought I was going to be able to do that. Why would you not be able to do that? I mean, yeah. Take that off for a moment. Oh, oh! You guys didn't. You guys didn't tell me. Um, it's probably the order of these things. Yeah, because I've got. I think it's failing on the wrong bit. It gets there. Okay. 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 Right. So now, there we go. Look. So now we can see what it's actually printing out, which is good because all of this ASCII stuff is like a bit. But wait, hold on. Yeah, because this is not very easy to read because of all the ASCII control codes. Right. But it's okay. So how do we turn off that stuff? I mean, I said with span events none. Hmm. What other type of things can we specify here? Spans are ignored. Not sure. Not sure. Have you guys seen that movie? What's it called? Idiocracy. Great movie. What's your name? Not sure. Tattooed. Not sure. Oh dear. Yeah, I'm not really sure what to do. Was this flat an event? What does this do? Jason, subscribe. Jason. Jason. Oh, Jason. Uh, Span list. We're not using JSON. I mean, what is this? Is this JSON? Kind of looks a bit like JSON. Let's see. Dot. What? What was the thing I was literally just looking at 2 seconds ago? Flatten. No. These are the things I can do. We've got compact event format. Let's have a look at this. Sets the event format that the describing bit will use to format events that occur. Format fields. What's this? So much the fields. Interesting. Interesting. Event formatter. Format.compact. Let's have a quick look. Tracing subscriber. Wait. So this is a subscriber. Then we've got this builder thing. And then we can go apparently format. Oh, I see. Yeah, fine. Dot, oops, dot. Yeah, I don't know how you get rid of all the other stuff. Instrument. Let's see what happens with this. Oh. Oh, there it goes. Let's see how it has changed it. Experimenting with the API by using it, you know. Well. That doesn't entirely suck. It's a bit. It's very interesting how this is working. It's pretty magic. It's not really what we want. We just want this sort of like super simple. I basically don't want any of this, and I don't want any of this. I just want this. But what I don't want to do. I'm not sure if you guys can understand what I'm trying to avoid here. What I don't want to do explicitly. Do not want to repeat this string stuff twice and give one to the tracing info thing and then one to something else. But I'm not sure whether I'm thinking about this right or not anyway by saying that. I just want formatted tracing output on standard out without any of all the instrumentation stuff around it, instrumentation and span stuff around it. Because this is the same as going tracing info, right? As opposed to log info, like whatever, right? I mean, what did that even do? I don't know. Did it do anything? Where did this log? What happened to that? Like what? Where did it go? Well, I don't know. I don't know. I don't know. I mean, I haven't configured any logger or anything. I was just sort of expecting it to just print it out on standard out, really. But yeah, let's let's not do that. Let's not do that. No, go away. Okay, well, I'm not too fussed about that. It's good enough for now. But it requires me to come back and poke it around a little bit. But this is fine. So we've got some standard out stuff, and it's showing you some things, and it's ridiculously verbose. But it's enough to allow us to move on. Let's add a fix me. Because we don't even have a proper test for this anyway at the moment. So right. So let's fix this up and make this work. Unexpected standard out. Just want to print. what happens if we extract this to a method? Print. Eh. And then we should be able to do the same thing here, right? And then let's have a look what it actually created. Well, yeah. It's got an underscore here. Why? Type, holder, play. Yeah, of course it's not. Predicate. Type annotations. Yeah, we know. Not allowed in type signatures. This is going to be a string. Oh no, stir, I think it was. I think. Yeah, there we go. So we print the standard out. That's what we expect to see. So let's go back to the bin. Let's go back to the bin. And somewhere in the figure tracing bit, we're doing this. And we're just going to comment this out for now. And we're going to say, fix me overly verbose. Fine. Because we have to come back and review this and make sure that we cover all the sort of all the things. And if you remember from the other day when I was talking about coverage reports, if you ran a coverage report on the tests at the moment, we would see that this bit isn't covered, which is interesting actually. Now that I fixed the project structure, it might actually be able to get a coverage report that includes all the tests. Let's just try that. Because we couldn't do it the other day. Because of the way that we were using cargo command. Here we go. Interesting. Let's see if it says anything about the bin file. Why is it not? Yeah, here we go. So these are the little things that you're supposed to see. So I wonder whether the macros are interfering with it. Because we clearly know that this is being run. But it's not showing the coverage reports for it. That's interesting. Interesting. Yeah. Looks like we're going to have to fiddle around with some of this. I mean, we know it's been run. Yeah, that's not really running properly, is it? That. All right, we'll ignore that problem. I have to come back to that and fix that. But there we are. Okay. Fine. So what I'm thinking about now is I'm hungry. I've been going on this for ages, and I'm also thinking about the ordering side of things. So in our test, we have this stuff, and what I'd like to do is say that these things happen in order, as opposed to just contains this. Because there's still no ordering specified. So it's almost like you need a predicate that consumes the string and then gives you back the remaining bit of the string, such that the other following predicates work on the remaining part of the string. Yeah, consuming. It's not just a predicate at that point, is it? Yeah. That's interesting. Interesting. I think I'll have to do a bit of research on that and find out how we can do that. Let me add a fix me or a to do. Assert the order is as follows. Currently, no ordering is no. Yeah. Yeah. Okay, we'll do that. Okay, let's do a commit because everything passes, right? What do we do? What do we do? What do we do? I spent 4 hours. 4 hours. And I've not used any GUI stuff. All I've been doing is trying to work out how to do things using new APIs and everything. It's quite a lot today. Right. To do. We still haven't made any progress on this. Not really. But we've added tracing. And the idea of adding the tracing is so that we can look for trace events that we're going to add to our GUI or text user interface. Yeah. Okay. So print the trace log content. Probably what we should do is move this bit up a bit instead of doing it there. So we'll print it out. And then do assertions on it. Let's see if that works or whether we get problems. We're printing the trace content and it should be immediately dropped there. I'm not sure. It might be dropped at the end of the block. But I guess you can force it to drop it by putting it in a block, right? Yeah. Okay. Okay, go on then. Yeah. Okay. Well, that's because I need to clone this one and not this one now. Crack on. Much compiling. Good. Good, 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 good. So what happens? Trace file. Yeah. Where we do this print thing here, we're doing a print lens, so that's why we've got these two blank lines here. We probably should print like a message or something. This. So if we do that, and then add that, go to this, message, and then go and then do something like message, and probably this shouldn't be called foo. This should be called value, content. Content's good stuff when dealing with like strings and files and all this kind of stuff. But technically, this is just, yeah, it's fine. Okay, fine. Right, and then it will be better. Go. What do we do? Uh-oh, what happened there? Okay. Oh, it's got this capturing thing. We might need to say move. Is it that? Am I doing that right? Probably not. Oh, no, 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 no. Yeah. Yeah. Not as easy as you might think. Yeah, no. I'm not doing that right. Oh, hold on. Maybe it's that. Yeah, that should be that. Yeah, yeah. Okay, we're good. Right. Yeah. This thing doesn't have that. Okay, good. So now it prints stood out and stood error like this. So we want a colon like that. That stood error. And then it prints some stuff. Okay, we're good. Right. So this thing is used by this. And we can go print and No? Oh. Oh dear. That's supposed to be stood. Error. You guys didn't tell me. You no help. That one stood out. That one stood error. And this one's stood out. Now, you might be saying, well, why are you printing it? When if it fails, it shows you what happened. That's no good if you've got a CI server and you've got a log and it says failed, because you don't see what it actually if it doesn't fail, you want to refer back to it just to see that it was there. If you've got a log file and you printed it, then you can see what the heck went on. So we've got stood out, stood error, print, stood error, like this. And we'll repeat this pattern for the other ones. And we're going to put it down. And it's going to go here, and that's going to go here. Stood out. And perhaps one more bracket, yes. And then this needs to be stood. And then we've got another one of those, which is the stood one, which is this. We've got asserting standard error and asserting standard out. We've got a missing bracket. Standard error, standard out, standard error, standard out. So then we're going to go standard error, standard out. At least be consistent. Standard error, and then out. Cool. So stood error, stood out. Yeah, see, this is much better. If you've got a log and you see this in it, you can see what's what in it. Yeah, we like that. That's much better. Yes, happy days. We like that. Okay, I mean, I'm fairly happy with that. Okay, let's do that commit message finally. So what are we doing? There's a few things we've done here. We get transition, assert to use trace logging. That's one of the things that we've done. Right. One of the other things we've done is improve test output by always printing stood out and stood error. You see, there's a problem. I wrote improve test output by always printing stood out and stood error, but that's not the case, because if the first assertion fails because of the predicates in it, then the other thing won't be printed. So if there's an error and we're not expecting any, we won't see standard out. It feels like we need to capture the standard out, print both standard error and standard out, then do the asserts on it. It could be improved. Not in this commit though. So let me take the word always off here. And then it's still correct. You know. Before corresponding assertions. Okay. Yeah, it's not ideal. Right. And then we've got our optional argument, which was a bit of a faff to do. And then we've got this, and we've got that. And we did some to-dos. We did some to-dos. Some of the to-dos that we did was in the loaders. So use trace logging in the loaders. So yes. Oh, use trace logging. Not sure about this instrumentation thing here. It sort of makes sense. And then here, what do we do? So we've added the trace log file argumenty thing. Let me look at this for a second. The no args thing. It says trace log file. Okay. But then in order to do that, we had to do some debug stuff. What else? What else have we got here? We configured our tracing. You know, if we use some other tracing library, then yeah, that's not so bad. And then we got some temporary things there which we deleted, and then this is where we did the transitioning, so that's all fine. Yeah, that's basically what we did, right? And then in order to do that, this will be interesting. We added tracing subscriber, and assert FS. That looks good, but what impact did that have? So I see many changes. So we've got assert FS, fine. And it's added loads of extra things. Crossbeam, glob set, glob walk, ignore, lazy static, log. I thought I took that off. New anti-term. Want cell overlay. Well, it's a lot of tracing has a large impact, but the tracing stuff is used quite widely, so it's pretty well tested. Small vec, sharded slabs, and locals. Perhaps it's possible to disable some of the features. Well, some of these new dependency. And leave that for a review in another commit. And this is for the terminal stuff, which we know we're going to use. Yeah, that's quite a lot. That was quite a lot. Okay, fine. Now this file is garbage. Let's just see if it reappears when I run the tests. It shouldn't do. It should just be because I ran it on the command line a minute ago. Because we're using a temporary trace file in our tests. What are all these to-dos? Overly waste, fine. Yeah, we've got the KiCad thingies. Let me go add KiCad support so that I don't have to keep going into these to look at them. Yeah, ordering. No. No. Fine. Just no. Loaders. What are we doing here? We're improving the to-dos. Improving the to-dos. Or card or support. Okay. All right, cool. In addition to all the other 1,000 to-dos that we've got to do. Right. I think that'll do for now. I might do another live stream a bit later, or I might just have an experiment with this TGUI stuff off stream. And then I'll see what I can come up with. Yeah. Okay. Well, thanks for watching, everybody. And don't forget to click the like button, and subscribe if you haven't already done that. And just remember, it's only software. How hard can it be? We'll see you on the next one.